So hopefully I didn't go over too far on that. So what else? So complete mess here. Things are getting commented out, right? Just kind of like shoehorning things in. The idea is to try to like shoehorn in the new normalized coordinate with breaking the minimal pieces possible. Like you want. Ideally, you want to do a little bit of refactor, a little bit of refactor, a little bit of refactor until you gradually get to a complete refactor, rather than try to do one big refactor, which will have multiple break sites if you make typos, right? You want it so when you're refactoring, you refactor in small steps so that if anything breaks along the way, it's just one point in the code where it's broken. Because if it breaks in multiple places at once, it can be very hard to isolate all of those places and fix them. But yeah, so this is just a complete mess, a complete mess, right? So, right, all this stuff is now commented out because this is the old testbed shader normalized coordinate or color. And now that we have that code I went over, this is no longer needed because the code up here to calculate those normalized coordinates will allow us to zoom in and out of stuff. So what else? So there was so originally right here this inbounds check. Before, this was X, Y, Z, and W, and it was the one of the old commands for getting the viewport, and now we're using one of the new commands that gets the viewport, and it gives us these nice to work with values that are consistent with the rest of the code base, because we have put a struct into our GLSL code. Now, a little bit of change had to be done because since these are now float coordinates, I had to make sure I did a uint cast so that the comparison was still valid, because GLSL is very picky with its types. Like, GLSL is very C-like, except that it will not let you do any type of implicit casts. Okay, so what else? So if you're not in bounds, we're gonna draw that border, right? So that was you know, that part, where are we? This little here part right here in our JavaScript testbed that we were doing to try to figure out the GLSL code. This little here is this code here, because we actually have to do it here, because now we're in the GLSL code, we got to handle that. Otherwise, we're just going to do one of our testbed shaders, because now we have all the input coordinates correctly wired up to them. So within the testbed shaders, there was a little bit of reworking here. Well, actually, I think this was already commented out before. Yeah, so there was, okay, yeah, maybe this wasn't reworked, but, okay, that's a lie. Neither of these shaders had to be reworked at all. It was just, we just changed the value of this coordinate that's loaded into the shader, and we didn't have to do anything. And now we have, like, zoom and pan. What else? So I added a little Mandelbrot shader to the shader index 2. So basically testbed shader 2 is now a Mandelbrot. And we have some time, but I am going to show off what it kind of does in the next video, just because, well, actually, let me think about that. Now I'll just show it off now, because I realize that this is kind of I have all these videos, and I want to keep them in a very specific order. So even though I want to show this to somebody later, now is not the time to record that video. So let's just go over here. Let's refresh, and let's open up our shaders. So here, let's do plus to zoom in, right? Which you've already seen this earlier, right? You got this part down here that's changing color because, right? Let's zoom in. This part changing color because that's actually the pixel where our viewport 2 data is stored. And if we go over to shader number 0, right, we got this. Now we can actually zoom in and out of this. So we can go, isn't that cool? Zoom in, zoom out. Okay, let's go over to the Mandelbrot. So nothing fancy, like a very basic Mandelbrot, but you can see that we are able to zoom in. But in order to really zoom into there, what we're probably going to need to do is shift over a little bit so we can do our pan like that, try to get something interesting kind of centered in the screen there, and then zoom in, right? Now, my zoom is only going to zoom until the viewport is about 1 pixel big, so we're not going to be able to actually like do like some type of infinite zoom where we zoom really deep. Like, you notice how it's like exponentially zooming in there because that viewport is approaching 1 pixel, so the viewport must be 1 pixel big right now, and yeah, we can't go any further than that. Actually, since I am using the very basic rectangle manipulation code, I believe once we zoom in more, we're going to start zooming out because the rectangle is now inverted on itself, and you can actually see that because the image is flipped, right? So right now we're zooming out, but it looks like we're zooming in until we're on the other side again. See? Topsy-turvy land. So that was, I actually just wanted to see what that behavior would look like. And it was also nice to just code very straightforward, rudimentary rectangle manipulation and worry about the more refined behavior later. Because right now, because the way our rectangle manipulation is, let's go over to a different shader. Oh boy, let's refresh. Right now our rectangle manipulation code does not account for the bounds of things. So if we go over here, since it doesn't account for the bounds, if we go left, we're gonna see some weird stuff because, you know, there is nothing over here. So when I go left, it stretches, and the reason why it's stretching is because the left side of the viewport hits, actually, hold on. You know what, I'm not sure why that is, because I thought I didn't put any, okay, this behavior is suggesting that I'm not letting the value go negative in the code. So I'm gonna go look over here for a second. We got 8 minutes. So if we go A2JS, and then it's rectangle inclusive, and then it's a function like that. So move left is what we're looking at, and if we go over to move left, let's see what we got here. So we have subtract. Okay, yeah, so that looks fine to me. But notice we're not doing any bounds checking or stopping the viewport from going over to the negative side. But you can't store negative numbers in the code. Well, maybe a negative number will come out by the way the bits are manipulated. But if we go over to sub, let's see what the we're using in a lot of places. A go-to definition might be a good thing right now. So let's see. Oh wait, maybe we are. Sub. So if the result is less than 0, then we're going to take the max value, add 1, and then minus the result, which would result to maxing out and counting down. So that's interesting that is... I would have expected a more extreme behavior than just, slight warping. So I don't know what that's about. And then it doesn't unstretch when I go back the other way. So I'm very skeptical. I think something is not quite right with this logic. I mean, it's erroneous to go over on that side, but okay, it's stretching. But then if I go down, it doesn't unstretch, right? Yeah, no unstretching, though. So if I go up, so we can get this to start to stretch, and we can make these, like, big rectangles. Okay, now if I go down, they're not going to go back into squares, are they? No, they're not. So, why would that be? Huh. Okay, well, I guess... Yeah, I don't quite get that behavior. I get that one part of the rectangle goes out of bounds before the other, and therefore it starts to get wrapped first. But I don't know. That just seems kind of weird. I don't know why that is. It's kind of suggesting that it kind of looks to me like almost looks like there's actual code used to stop my rectangle from moving too far, but not according to the code here that I see. There's nothing that says, oh, once you hit the edge to just stop moving. But yet that seems to be the kind of behavior that I'm seeing, or maybe I'm not. I don't know. Yeah, I don't know. It's not the behavior I expected, but now that I think of it, I'm not sure what behavior I expected. But yeah, so we have these straightforward rectangular manipulation functions that are being called when I press the keys. And then we have these more complicated rectangle manipulation functions that I need to try out. These ones are going to make sure that the rectangle can't go outside of the bounds of what it's supposed to be sampling. So if for example, rectangle viewport 2, the viewport 2 viewport is not supposed to go outside of viewport C. So viewport 2 right here should, viewport 2, which is right here, should never go outside of viewport C right here. That would be erroneous behavior. And I think that's another reason why I have viewport 2 instead of trying to reuse viewport 1, because viewport 1 is to sample a buffer that is, it's off-screen data. Viewport 1 is used to sample like a tile map stored as a bitmap, stored in a texture on the GPU, or not on the GPU, but in VRAM, whatever. And so they have different rules as to what makes them valid or invalid. And sure, I could just share the coordinate, share the object, and use it as viewport 2 in some code, and use it as viewport 1 in other code. No, I don't want to do that because I don't want to have tangled state, and it's better just to use more variables than to start trying to reuse variables and tangle up your state. I mean, if we've learned anything from OpenGL, it's that state machines can be a pain in the ass to work with. So, correct state management is kind of important. So yeah, that's about it, I think. Let's go look and see what else we have here, I guess. Yeah, there's yeah, there's a oh, so we already kind of went over that, but yeah, there's a lot here. So there was one bug I found in the code while I was working, and it was for this the putting the global variable right here. If we go to see where that's called, so let's go find you. So not there. So okay, there was two errors. So right now you'll see in this code for editor 1 for the keyboard bindings, you'll see viewport 2 is here in the orange, and you'll notice that the 2 is not colored. That's because originally it was viewport 1, and then I refactored it out of there because I was like, okay, why is this not working? Oh yeah, it's because my code isn't actually wired up to that viewport, so that was a problem. But let's go to the other problems. Let's go Control F and go find the other location where we're putting the value. So put global variable, we're going to put VP2. We put VP2 like in the global init002 function. This is where this is, and we're just putting the initial value of rectangle viewport 2. And the problem I was having was originally, if we look at these initial values here, they were incorrect. They were like negatives, and I was like, why are these all negatives? And we go over here and we see, oh yeah, negative 55, negative 66, negative 77. It's like, wait a second, why? What? You know, why are the... That doesn't make sense. I thought I changed that. And, right? And down here, I did change it. So, you see, I do an assignment to... I make VP2 perfectly line up with VPC. Right here. VP2 is perfectly lining up with VPC, so that at the start, when you start up the game, there is no zooming or panning at all, because if viewport 2 is coincidental with viewport C, then the GL frag chords do not get transformed in any way. The thing I screwed up on here was originally I did not have this part. See this part, the INI val? I did not have that. I just went global data dot this and global data dot this. And so I took null or undefined, and then I assigned it to something that didn't exist. So that made it so that the actual viewport values never got written to. And because they never got written to, because I forgot this part, the original value for VP2, if we go up here, negative 55, negative 66, negative 77, negative 88, they stayed in the code. And when I was debugging the code, I was able to see these negative values and more easily find where the problem was, because I could see that they had already been assigned to this, but one of the other assignments was not working. So using these kind of trap values rather than just setting something to 0 is very helpful, because if these were just all set to 0, I don't think it would have been as informative as these values. Because when you see negative 55, negative 66, negative 77, negative 88, it's like, without a doubt, it is coming from here, right? But if you just see 0, 0, 0, and 0, there's a lot more possibilities, right? Like, it could have been 0 initialized in multiple places, right? But this gave it away. Because if these were all initialized to 0 here, then maybe I would have been looking at this code and being like, oh, I guess maybe this is somehow 0 and we're assigning 0 into here. But nope, because this is the only place I'm using negative 55, negative 66, etc., right? So trying to keep your trap values unique, right? So I'm going to have to get more creative with those negative values as I go on when I'm using trap values in other places. But yeah, definitely using trap values when you can will make things a little bit easier to find, because it'll be more obvious the origin of where those problems are. What else? I think that about covers it. Geez, there's a lot of stuff in here. Yeah, there's like Alright, so we're at like, we're in the 6,000 region, so maybe we'll have something substantial once we get to like 20,000. We still have not implemented the code from the previous playlist yet, but we are very close to doing that. And then once that has been fully implemented, then this playlist will be done. And this has turned into more of half-assed code reviews than me just coding while talking. And that is just because I cannot code efficiently while talking at the same time. Or I just don't want to. Maybe I just want to listen to my techno music while I code. But I'm going to keep on just giving overviews of what's going on and just keep on coding. But I don't know. I just do not have the willpower to explicitly explain everything, because there's a lot here. Doesn't really do too much. I mean, okay, I don't know. Doing a lot, that's very relative, I guess. But it doesn't really do too much yet. But we have a pretty good foundation, though I do need to clean some stuff up. Some of this stuff is really messy, especially the GLSL code. It's just completely trashed all over the place. But the thing is that having a very clean style, a very orderly style of coding, makes it very obvious which parts need attention, right? Because, obviously this does not need attention here, right? Obviously this has been thought through and meticulously put there. Everything's nicely lined up. This does not need attention, right? You don't even have to look at any comments. You can just visually identify where the problems are, right? You look at this weird-ass blob of color, and you know this needs attention, You look at this little part leaking off the screen over here, right here. You know that needs attention, right? Same thing with this, right? Like this. Obviously, a big, huge commented out section right here. Okay, that needs attention, right? Oh, this looks pretty this diagram right here looks pretty orderly. That's good. But then what's all this commented out weird stuff? Why aren't things aligned anymore? Okay, that needs attention, right? So now I know the parts where I need to clean them up. And so before I go any further with this code, I think what I'm going to do is I'm probably just going to start cleaning stuff up until it's in a nice state, and then I'm going to add more code. I think that's the way I want to go. Yeah, that makes sense, because I think after I've cleaned up, I think the next part will actually be getting the previous playlist code in here. Yeah, I think so. Well, we're really close. Did not want this to turn into like 100 videos. Oh well.